to another session of virtual classes of science here. Here we are going to continue with the questions of equations of motion which are relevant for your entrance examinations. So I call this one as a session of crash on equations of motion. Here we have the question number 1, in which a car is moving with 10 meter per second stopped in 20 meter. If the initial velocity of the car was 30 meters per second, it can be stopped by same force in, options are 20 by 3 meter as option A, option B is 20 meter, option C is 60 meter, and option D is 180 meter. The problem is obviously based on a stopping distance question, the theory which we have discussed in the concept session as well as the initial session of the crash on equations of motion, and all of you knows that the stopping distance is equal to u square by 2a, which is an outcome of the equation v square is equal to u square plus 2as. And you all know that stopping means v is turning to 0 ultimately, and a is negative because it's a retardation or retarding force. So from this we are referring as same force, that means same acceleration. In two occasions we have same accelerations. So I can use the proportionality, S is proportional to u square. We will form two equations in which S1 is the stopping distance in the first case, which is proportional to u1 square, and S2 which is proportional to u2 square. Proportionality, when you derive, it becomes equality. So S1 by S2 is equal to u1 square by u2 square. S1 is known as 20 meter. S2 is the unknown distance. Let me take it as x. u1 square is, say, 10 meter per second. So 10 square. And u2 square is 30 square. This becomes 1 by 9. So what is x then? 20 times 9, which is 180 meter. Look at the option. This will be the right answer for you. We are into the second question of equations of motion, in which the question is a lengthy one. You can see a body travels 15 seconds starting from rest. So we have initial velocity is equal to 0 with constant acceleration. That is one condition which is given. If it travels S1, S2 and S3 in the first 5 seconds, second 5 seconds and next 5 seconds respectively, the ratio between S1, S2 and S3 is. The options given are option A, S1, S2, S3 are equal, option B, 5 S1 is equal to 3 S2 is equal to S3, and option C, S1 is equal to S2 by 3, S3 by 5, and option D, S1 is equal to S2 by 5 and S3 by 3. So our aim is to find out the displacements in different time intervals. So we have 3 time intervals after starting from rest. Let me just demonstrate that one by the help of a diagram. We have u is equal to 0 at t is equal to 0. Let me take it as t is equal to 0. And it covers, say, S1 distance in the time interval, say t is equal to 5 seconds, and S2 distance in another time interval of 5 seconds, and S3 time interval, another time interval of 5 seconds. So we have divided the total 15 seconds into first 5, second 5 and third 5. So our aim is to use the equation, say S is equal to ut plus half a t square. For each interval, the t is 5 seconds, we know. And for all the intervals, acceleration is nothing but that is a itself. So our aim is to get what? Our aim is to get u value for each different interval. So we have this one as a first interval. Say let us that it equal to u1. We don't know what is u2. That is the velocity with which the particle starts after 5 seconds. And this one u3, the velocity by which the particle starts after 10 seconds. we have to find that velocities. So we have u1 is equal to, say nothing but 0 itself. I have to get u2. What is u2 actually? That is the final velocity which is gained after traveling 5 seconds with an acceleration of a. So we can call the velocity attained after 5 seconds is nothing but that is the initial velocity for the second interval. So I will write u2 is equal to u1 plus a into 5 seconds using v is equal to u plus at. u1 is 0, so u2 is equal to 5a. We got u2 is equal to 5a. What about u3? That will be the velocity gained by the particle after traveling 10 seconds with the same acceleration starting from rest. So u2 is equal to, say, u1 plus a into 10. So u2 is equal to 10a. I got every parameter. So I am calculating for the first interval. What is S1? S1 is u1t plus half a t1 square. T1 square or t square itself. We know that t is 5 itself. So u1t. u1 is 0. 0 into 5. Half a 5 square. 25 by 2, that is 12.5a. We got S1. What is U2? U2 is 5a. Oh, I'm sorry, this is nothing but U2. This is U3 itself, okay? That is U3. You got U1, U2 and U3. That is just, when I wrote it like U2, okay? This is U3 only. So what is S2? For the particle S2 is u2t plus half a t square. u2 is 5a, t is 5 plus half a 5 square. We know that every interval is 5 seconds each and u2 is 5 and a is a itself. Simplifying, this is 25a plus 12.5, we will get 37.5a. Similarly, you can proceed with S3. What is S3? S3 is U3T. What is U3? That is 10A. T is 5 plus half A 5 square. This is 50A plus 12.8, 62.5A. You got S1 as 12.5A. S2 is 37.5A, that is 3 times of S1. S3 is 62.5, that is 5 times of S1. Look at the given alternatives. Which is the right option now? We can say S1 is equal to S2 divided by 3, that is 37.5 divided by 3 will give you 12.5. S3 divided by 5, that is 62.5 divided by 5 will give you 12.5. So which is the right option? Right option is C. You get the relationship between S1 and S2. Stopping problem here. A bullet has to be stopped. Problem is, a bullet loses 1 by 20th of its velocity passing through a plank, a wooden plank. The least number of planks are required to stop the bullet is. Given that all the planks offer same acceleration or maybe retardation, you know that plank will be offering retardation when the bullet is trying to go through that, it will oppose and its velocity is decreasing. Options A is 10, B is 11, C is 12 and D is 23. Let us assume that we require n number of planks. We don't know what is n, that is our question. Each of them is offering a retardation, say minus a. And each has got a thickness of, say, s. And if that n number of planks are piled together, then the bullet will come to stop. That is my assumption. That means final velocity of the bullet becomes 0. Initially, it is moving with u. Let us formulate the equation. V square is equal to u square plus 2as. V square is equal to u square plus 2as. This turns to be V is 0, u is u square, a is negative, and there are are n number of planks, so minus 2ans. I can write n is equal to, rearranging, I can write 2ans is equal to u square, or n is equal to u square divided by 2as. I got this one in terms of u and n. Now our aim is to replace either u or 2as. Try to do that. We have one given data. That is, when this is passing through one plank, when bullet is passing through one plank, its velocity loses by 1/20th of the initial velocity. That means when it passes through that one, its velocity becomes, if initially it was u, it is reducing by u by 20. Or we can write that is equal to what? 19 u by 20. This is what is happening when it is moving through one plank. And one plank has got how much thickness? S is the thickness. Still its retardation will be minus a. Again I am going to write v square is equal to u square plus 2as for one plank. V square is 19 u by 20 the whole square. U square is u square minus 2as. Let me take that 2as to this side because 2as is an unknown quantity here. So 2as can be written as u square minus 19 the square is 361, 20 the square is 400 u square. If you rearrange, this becomes 39 divided by 400 u square. We got the expression of 2as in terms of u square. Substitute here, my n will become u square divided by 39 divided by 400 times u square. U square cancels. This is 400 divided by 39. This is greater than 10, less than 12, because we know that 390. 10 into the 39 will be 390. Remaining is 10. So that is greater than 10, less than 12. That means 10 number of planks will not be able to stop it. We require number of planks greater than 10. So we can say which will be the right answer. We need 11 number of planks to stop it. We have a very good problem to understand the concept of average velocities starting with different intervals. The problem is a point moves with uniform acceleration. So obviously the problem is related to equations of motion. All the equations of motion are relevant because it is with the uniform acceleration. And if v1, v2, v3 denote average velocities in successive time intervals t1, t2 and t3, then relations is the question. Option A, v1 minus v2 is to v2 minus v3 is equal to t1 minus t2 is to t2 plus t3. Option B, v1 minus v2 is to v2 minus v3 is equal to t1 plus t2 is to t2 plus t3. And option C, v1 minus v2 is to v2 minus v3 is equal to t1 plus t2 is to t2 minus t3. And option D, v1 minus v2 is to v2 minus v3 is equal to t1 minus t2 is to t2 minus t3. How to start with and from where to start with? Problem, I will start from the concept of uniform acceleration, that I have got a particle, a point which is moving with uniform acceleration. Say initially it has got a velocity of u, it has an acceleration a, it covers successive time intervals say t1 and t2 and t3. And what is given for us? In the first interval it has got an average velocity v1, second interval it has got an average velocity v2, and third interval it has got an average velocity v3. So previously let us first calculate the value for the first time interval t1. After covering t1, what will be the final velocity? We can use the equation v1 or V1 can be written as initial velocity u plus a into t1. We got the value of V1. So if it covers a value of t2, what is the total time taken? T1 plus t2. This is the first interval. This is the second interval. So the total time is t1 plus t2. After that, the velocity attained is v2. What was the initial value? U plus a into t1 plus t2. Proceeding to the third one, v3 can be written as u plus a into t1 plus t2 plus t3 by simple application of the first equation of motion. We got the relations v1, v2, v3. Now I am entering into the concept of average velocity. What is average velocity? For a constantly accelerated motion, average velocity is always equal to initial velocity plus final velocity divided by 2. So I can write any of these. The first interval v1 can be written as final velocity is v1 itself, initial it is u by 2. What is v2? Second interval, the average value we can put it as v1 plus v2 divided by 2. What is v3? v2 plus v3 divided by 2. So we got the equations v1, v2 and v3. Now let us substitute to these equations the values of v1, v2, v3. So the first one, v1 will become u plus, what is v1 from this? U plus at1. U plus at1 by 2. U plus u is 2u. 2u by 2 will give you u itself. U plus at1 by 2 is half at1. I am going to the second one, v2. What is v2? v1 plus v2 divided by 2. What is v1? U plus at1. What is v2? U plus a into t1 plus t2. Substituting u plus at1 plus u plus at1 plus at2 by 2. Still you can see u plus u. 2u by 2, that is u. at1 plus at1, 2at1 by 2, that is at1. at2 by 2, half at2. Proceed into the v3. What is v3? v2 plus v3 by 2. Substitute u plus at1 plus at2. v3 is u plus at1 plus at2 at3 whole divided by 2. Repeating terms are u and u will give you only u. at1 will give you at1. at2 will give you at2 plus half at3. We got v1, v2, v3. Our aim is to find v1 minus v2 and v2 minus v3. Let us try to do that. v1 minus v2 and v2 minus v3. What is v1 minus v2? v1 minus v2. This minus this. U minus u will become 0. Half 81 minus 81 will give you minus half 81. Minus half 81. Then there is half 82 in the second part. So that also will become minus half 82. Take minus half a common. This will become t1 plus t2. Proceeding into the next one, v2 minus v3. That is this term minus this term. U minus u 0. 81 minus 81 0. Half 82 minus 82 will give you minus half 82. There is another term over here. There is no term over here which is t3. So that is again minus half t3. Take minus half a common. This becomes t2 plus t3. What you are doing? Dividing this with this. v1 minus v2 is 2v2 minus v3. That means divide this term with this term. minus half a minus half a. When you cut it off, you have only t1 plus t2 divided by t2 plus t3. Which will be the option? Option is option B. You got yet another question on kinematics, and we cannot say that it is purely a one-dimensional problem because you can see it has got x-axis and y-axis in the description. But anyway, we can solve it by using the kinematics equations in 1D. We have a body starts from rest from origin with acceleration 6 meter per second square along x-axis and 8 meter per second square along y-axis. Obviously, this is a two-dimensional problem. The question is its distance from origin after 4 seconds. Problem to analyze it is very easy to do because we have s is equal to ut plus half a t square, and it is given that u is 0. So along the x-axis we have an acceleration 6 meter per second square. I'll call it as ax. Along the y-axis I have 8 meter per second square. We'll call it as ay. Using the same equation, I can take x component as x is equal to half axt square. That is half ax is 6 t square. How much is the time taken? 4 seconds. 4 square is 16. 3 into 16 is 48 meter. We got the x coordinate. What about y coordinate? Half a y t square. Half a y is 8, still 16. We got 8 into 8, 64 meter. We got the x coordinate and y coordinate of the distance parameter or displacement vector, we can say. But the question is only for distance. That means the magnitude only is the question. You can find out the distance as, say, d is equal to root of x square plus y square. X square is 48 square plus 64 square, which gives 18 meter as the right option. So we can choose option C as the right one. You may extend this one into the two dimension. To find a direction. If there is a problem like if you want to find a displacement, obviously you have to find a direction also. Now you can plot this one on a graph. The body starts from origin. You have an acceleration along the x-axis at 6 meter per second square and along y-axis as 8 meter per second square. And after some time you got x coordinate as 48, say 48 over here, and y coordinate is 64. So you know that the position of the particle will be somewhere over here. You can say r, this is y coordinate and this is x coordinate. You can say this magnitude we have found it as 80 meter, which is the hypotenuse of the right triangle. Suppose you have to find the angle subtended, because to find what the displacement of previously you have to mention the angle. What will be tan alpha as per the vector analysis? All of you know that it is y by x. Tan alpha, which alpha is angle made with x-axis. Y by x, you can put it as 64 divided by 48. Say 4 by 3, 1.33333 is something. So we can put alpha is equal to tan inverse of 1.33. So I just extended the problem not merely from the magnitude to the direction. So you can see the magnitude as well as direction if it is a 2D problem. With this, the fifth question, we are winding up the session of questions on equations of motion. We will have one more session added into the same concepts, in which we will be seeing more problems related to equations of motion and related theory. Thank you. Thank you for watching.